We're being asked to solve the following differential equation. It appears to be homogeneous. Let's check. So we're going to think of this as big M and this as big N. And what we'll do is we'll look at M of Tx, Ty. So that will be Tx minus Ty. And then you can factor out a t, so you end up with t parentheses x minus y. And we said that x minus y was big M, so this is t times m of xy. So big M is homogeneous of degree 1. Now we'll check big N. So big N of Tx, Ty, this is equal to Tx. But x is big N, so this is simply t times n of xy. So big N is homogeneous of degree 1. So if big M and big N are both homogeneous of the same degree, we say we have a homogeneous differential equation. Now, this is not to be confused with homogeneous in the other sense, which you study later for higher order equations. So we have a homogeneous equation, so we can make a substitution. So we have a choice. We can use y equals ux, or we can use x equals vy. So if we use y equals ux, then we have dy equals u dx plus x du. And if we use x equals vy, then we have dx equals v dy plus y dv. So we have to make a choice, and either works. It seems that if we use dx, we're going to have to end up distributing x minus y times this sum, so we're going to have to FOIL. So let's not use this one. Let's go with this one, as it appears to be easier. So now we'll carefully, very, very carefully make the substitution. So we still have x. So we have parentheses. Let me do it down here. X. And then minus, and then y is ux. So ux, and then dx. Plus, and then we have the x here. So x. And then we have the dy. And dy is this right here. U dx plus x du. So u dx plus x du. It's very, very easy to mess these up. And this is equal to 0. Let's carefully distribute. So x times dx is simply x dx. So x dx. And then minus ux dx. Ux dx. Plus, here we have xu dx. So xu dx. And then here we have x squared du. X squared du. And this is equal to 0. Let's see if anything here cancels. Looks like these guys go away. And so we have x dx. And usually that happens. It's a good sign. So x squared du. And this is equal to 0. Our differential equation should be separable. Let's go ahead and subtract the x squared. So we have x dx equals negative x squared du. Dividing both sides by x squared, I'll leave the negative over here on the right-hand side. We end up with 1 over x dx equals negative du, right? Because x over x squared is 1 over x. Now we can integrate both sides, and so we end up with the natural log of the absolute value of x equals negative u plus a constant which we'll call c. Keep in mind in all of this that y is equal to ux. And that means that you could divide by x, that means that u is equal to y over x. So we have the natural log of the absolute value of x, and that's equal to negative y over x plus c. If we subtract the c, we end up with negative y over x equals natural log absolute value of x minus c. And if we multiply by x, we have negative y equals x, parentheses, natural log absolute value of x minus c. And finally, we can multiply by negative 1 and we end up with this expression here. And if you prefer to distribute the -1 to make it look better, you could do that. So you end up with y equals x, parentheses. So -1 times this guy, it's going to make this negative, and then the c will become positive. So it's going to be positive c minus natural log absolute value of x. And that is the final answer. I hope that helps.